What if everything you believed about supplements was wrong? What if high-protein diets don't wreck your kidneys? What if creatine isn't just for bodybuilders, but could actually make you smarter? And what if, despite the hype, most of what you're buying in the supplement aisle is complete garbage? That's exactly what today's guest is here to tell us. Dr. Jose Antonio is the co-founder of the International Society of Sports Nutrition, the world's leading organization on science-backed nutrition for athletes, and he's published over 150 studies. He's written the books, he's fought the critics, and he has won, or I would at least say that he's winning that fight. So this is the man who stood in front of the industry, right? And he said, no, you're wrong about protein, you're wrong about creatine, and you're misleading the people who need the truth the most, which we know, most of you who are listening are the trainers, the gym owners, the athletes. In today's episode, we're really asking, how much protein do you need to build muscle, lose fat, and or stay healthy? Are supplements expensive waste, right? Expensive urine? Or are we missing out on the most powerful performance tools available? Why are some athletes faster, stronger, and leaner? And how can you actually coach clients to get there? We're also diving into the future of sports nutrition. Could creatine help your brain? Is there a supplement that could improve eye tracking for athletes, right? So you have that hand-eye coordination. And what happens when you legally allow athletes to use performance-enhancing drugs inside the enhanced games? This isn't just about science, it's about your business, your clients, and your edge as a coach or gym owner. This is Sweat Success. Let's get into it. All right, so Dr. Antonio, let's just start with kind of the man behind the PhD. You know, why did you get into this? Why did you start the ISSN? You're kind of passionate. Like, let's talk about you for a second, who you are, and you know, a little bit of the origin story.
Well, thanks for having me on your show, Michael. You're asking a really big question, because a lot of this is an evolution of things that, let's just say, like, for instance, jumping to the ISSN, that was not anything I planned. It wasn't even anything I wanted to do, but I'll tell you what sort of led up to that point where, you know, we started the organization. You know, my interest in exercise and then secondarily nutrition actually started when I was a kid watching, and this is way before your time, unfortunately, watching the initial Kung Fu movies that came to the United States in the 70s. They called them chop socky movies. And I thought, wow, this stuff is really cool. I was a big fan of boxing at the time. I loved Muhammad Ali. I watched all those prize fights. Actually, it was on closed circuit TV. You couldn't watch it. Obviously, there was no Netflix or anything like that. So my dad would bring his kids, you know, myself and my 4 other brothers, to basically a theater in downtown Washington, D.C., watch these boxing matches, you know, Muhammad Ali versus Joe Frazier, George Foreman, et cetera, et cetera. But I was always fascinated by speed. And I remember watching Ali fight. I was like, dang, for a big guy, he's really fast. Bruce Lee was one of my idols as a kid. I was like, wow, this guy's really fast. And so I think most young boys growing up are enamored by strength. They see a large guy and like, wow, that guy's really strong. I was always fascinated by speed, because at least with strength, you could sort of say, well, bigger guys tend to be stronger, so it's not mysterious. With speed, it's a lot different, because it's like, why are some people just really fast? And can you train someone to be really fast? And later on, I realized you can train everyone to be faster. You just can't train them to be fast. And so it was the Summer Olympics. I think it was either 72 or 76. I forget which year. There was a Russian sprinter named Valery Borsov, and he doubled in the 100 and 200 meter dash. He won the gold. And an American was favored to win. And Americans always did poorly in sprints for whatever reason back then. But anyways, I was watching this special about how Russians, they will do some of these. Actually, at the time it was Soviet Union. We just call it Russia now. They do unorthodox training. And one of the things he did, which, you know, I'm just in college, you know, I'm in high school at the time. I'm thinking, wow, they do downhill sprinting to help teach leg turnover. Yeah, which everybody does now if you're a sprinter. But back then it was like, oh, wow, these, you know, athletes from the Soviet Union, they do all this sort of different stuff. And they, you know, they're able to turn out all these athletes. So from that point on, I was like, wow, this exercise stuff is super cool. But when I went to college, I went to the American University in Washington, D.C., and this is in the 1980s. I like using presidents as frame of reference. This is when Ronald Reagan was president. So I'm sure some of your listeners are like, Holy shit, that's a long time ago. Ronald Reagan, when was that? So I remember my first semester, and this always, a lot of my students are like flabbergasted when I say this. I say, I was actually a history major my first semester in college because I actually like reading history, believe it or not. I used to watch the History Channel. I'll read stuff for fun. But then I realized as a history major, and I don't know what it's like now, back then, is you are reading a lot, like a lot. And I mean, to study history, you got to read a lot. And I'm like, dang, I like history for fun. I don't know if I want to major in it. So my dad, who was a physician, he was an MD. He specialized in gastroenterology. He said, why don't you just go pre-med? I mean, and you have the same name I do. You could be a doctor. And I'm thinking, I don't really like medicine. I don't really want to be a doctor because I remember as a kid going with my dad, he would do rounds. And the first thing that sort of planted in my mind was, God, I hate the smell of hospitals.
Yeah.
I can't, and being around sick people, I'm like, I don't, whoever can do it, that's great, but it's depressing. Yeah. I mean, I'm like, okay, I have zero interest in this. However, I liked exercise and I was interested in human performance. So I was a biology major with the intent, and this is my sophomore year. I said, you know what? I think I'm going to get a PhD in this. I'm not sure how you do it, but I'll figure it out along the way. So I got a biology undergrad. I went to Kent State, got a master's degree in exercise phys. And that's where I was first introduced to Dr. Peter Lemon, who was one of the first to actually say, people who work out actually need more protein. Oh my God, we need more protein. And, and to this day, there's still people who don't believe that. But I got my master's degree there. Then I got my PhD at the University of Texas Southwestern Medical Center in Dallas. And let me tell you a little bit about how I chose the field of study. Now, at this point, I'm really interested in exercise, but also sports nutrition and supplements. I remember reading all the old muscle magazines, the Weider publications, Muscle and Fitness, et cetera, et cetera.
It's all fact. Whatever is in there is all fact.
Yeah, and everyone's like, do you read Muscle and Fiction? I'm like, yeah, you know what? It can't be all wrong. So I'm going to keep reading this stuff. I find it interesting. And when I first talked to people, both faculty and other grad students about, studying sports nutrition for a PhD, everyone laughed. They're like, sports nutrition, that's not a real field. Nobody studies sports nutrition or supplements. And so really, I made the pragmatic decision, okay, I'm going to study muscle physiology because it was accepted, even though I really wanted to study sports nutrition. But I tell students all the time, when you're getting a PhD, make the pragmatic decision of something that will get you the degree, do all the fun stuff later on. So I studied, I don't know how familiar you are with the muscle physiology stuff, but my dissertation focused on muscle fiber hypertrophy and hyperplasia. I used animal models to study it.
I have a question for you on hyperplasia, but go ahead.
Yeah. So we did some really cool animal work. I'm looking at muscle fiber hyperplasia. So I graduated when Bill Clinton was president with my PhD. And so people are like, so what'd you do after that? Well, I did a short postdoc. And then my first job was writing for muscle magazines. So this is what's interesting. During this time, everyone's criticizing the muscle mags. They're like, there's no science. It's all bullshit. It's baloney. And I'm thinking, okay, well, we could either complain about it or we can do something about it. Why don't they hire a science editor? And so I actually convinced the Weider Publications to hire me as a science editor remotely. They wanted me to move to Woodland Hills, California. I'm like, I'm not leaving. At the time I was in Texas. I'm like, I'm not leaving Texas to go to California. I have no interest in living in California. However, I will work for less money to stay in Texas to write. So I did that for 2 years. And, I'm hooked on the sports nutrition stuff. So sort of make a long story short, eventually my wife and I leave Texas, move to Nebraska. I would teach at the University of Nebraska in Kearney. Now we're talking late 1990s. And sports nutrition still is not accepted as a field of study, even though it's starting to trickle in. So let's see, early 2000s, and this is really, the year 2000 is sort of the break point. Before the year 2000, there were very few, if any, sports nutrition courses anywhere in the country, at any college. After the year 2000, it started to grow slowly, and then it was a flood. like today, 2025, there's a sports nutrition course in probably every major college now. Mm-hmm. Whereas pre-2000, there were none. So why did we come up with the ISSN? Well, it was actually the dietetics conference. It was organized by my good friend Doug Kalman. He organized a conference. It was the subgroup, and wow, this is like 25 years ago. It was a subgroup of the American Dietetics Association called SCAN. SCAN is the Sports Cardiovascular Wellness, whatever. And the focus was sports nutrition. So he organized it. Doug's a PhD RD now. And we're all sitting at dinner and we realize that virtually everyone who's giving a talk on sports nutrition is not a dietitian. Mm-hmm. We're all trained basically in exercise science. So the people who do research in, quote, sports nutrition are actually not nutritionists. Our interest is exercise, and using exercise as a model. What nutritional things can we do to make us better with exercise versus, people say, you're interested in clinical nutrition. I'm like, marginally, but at the end of the day, I want to know what makes people better athletically. That's it. Mm-hmm. You want to run faster? Let's figure it out. You want to lift more weights? Let's figure it out. So in the year 2003, we had our 2003, 2004, we organized our first conference. And we got a lot of pushback. There were still people in, quote, the sports science field who thought this was the dumbest idea ever. And which is kind of funny because now they all love sports nutrition. The people who are the biggest critics are like, will never admit they're wrong, but they love sports nutrition. Oh, yeah. They talk about supplements. They even have students who do research in this stuff. So from that point on, up until 2025, sports nutrition grew like crazy. Now, what's interesting, there are little sort of trials and tribulations I personally went through to get to this point. And I'll tell you a quick story. I won't mention names, but it was at a conference, American College of Sports Medicine. And myself and my good friend, Dr. Jeff Stout, who's now at the University of Central Florida, we were the first to actually write a book on sports supplements. And we purposely used the word supplement because we knew it would trigger a lot of people. Mm-hmm. They're like, supplements, it all suck. None of it works. I'm like, no, we're going to use the word supplements. So we gave a talk at the American College of Sports Medicine. People either loved it or hated it. And the people that hated it made it clear that they hated it. And I'm like, wow, these people, why would you get pissed about sports nutrition? Yeah. I mean, it really makes some people mad. They're like, I can't believe you guys are talking about this stuff. This stuff is all bullshit. And I'm thinking, well, it's not all bullshit because there is data. But anyways, that's not the best part. The best part is this. After the talk, people were like, wow, that's the first time we've heard anything about supplements at this conference. Dr. Jeff Stout and I were at a cocktail party happy hour thing. We're just minding our own business. And the president of the organization walks up to us and she says, and I'm trying to think the exact word. She says, gentlemen, if you want to have a career, don't do any research in supplements. And I was thinking, did I hear that right? And I'm looking at Jeff Stout. I'm like, did she say don't do research in this? Isn't the whole point of science to do research in it? Yeah. And so that told you that encapsulates the zeitgeist of the time, that it was so anti-sport supplements that it's like, okay, clearly we've touched the nerve. Either we are right or they are right. We both can't be right. We think this is the late 90s, early 2000s. Yes. So not even that long ago. Mm-hmm. So, it's either we're just total idiots and we think there's something there, or these are, and I hate to say it, but they're basically ideologues. It's like they were so married to the idea that supplements, even the thing of it, the study of supplements was such a waste of time that they couldn't divorce themselves from that view. And so I always tell Jeff, I'm like, hey, we lost all these battles, but we won the war. And that's really what matters. Sure, we got criticized, but who gives a shit? We got criticized. I mean, if you want to move a field, you got to think differently than everyone else, especially if everyone else is thinking wrong. So that's sort of the Cliff Notes version of how I got to where I am now. And to this day, here's what's interesting. I have currently have 3 PhD students, who've all done part of their doctoral work is on supplements. So it's kind of strange. We went from, oh, that's a total waste of time to, wow, we have all these PhD students studying it now. So it's, it's not like it happened, quickly, but it happened so slowly over a bit of time, that you don't realize it's like, God, myself and a lot of my colleagues, we went through a lot of shit just to get to where we are. And, and it's during the time, it's like, wow.
You paved the way. That was the reality. Like there was no path for that at the time.
There was no path. Yeah. So, but it's been a fun ride. I'll tell you that. It's been a fun ride. And now ISSN is global. We're going to have a conference in Italy. We have a conference in Colombia. I'm working with some people in Chile. We might have a conference in Chile. And of course, our national meeting is always in Florida. I don't know where you're based, Michael. Are you?
I'm in Florida. Yeah. So I'm here.
Oh, well, then you need to come to our conference. It's in El Rey Beach.
I will. Yeah. I'll be there.
Yeah. It's a lot of fun. I don't know how many other science conferences you've been to, but ours is actually fun. All the other ones are actually kind of boring. I'll be honest. They're boring.
I can only imagine.
Yeah.
So I want to jump into protein, and I want to talk a little bit about myostatin. I want to talk about some of the things that you've done in research that has had a huge impact. I mean, you probably published the most on protein than anyone else. And the common thread that I hear in gyms is trainers are constantly referring to 1 pound per gram, or 1 gram per pound of body weight.
I like 1 pound per gram.
Yeah. That's a lot, right? So in my opinion, I've always seen this as the other way around, that it was 1 gram per kilogram. And I have kind of like this little way, I should say, it's a tested way through my own research with my own trials of customers. And what I would do is I just put them on, and most of it's based on some of the stuff that you've actually published, but I would take their body weight in kilograms and then give them anywhere from 0.8 to 1.6 grams of protein per their body weight in kilograms based on their lifestyle. So if they were, athletes, maybe I'd bump that up even a little bit, and then we just monitor and fluctuate that number. And then the amount of protein was, based on the amount of protein that they were given, their total caloric intake was anywhere from, their protein intake was 20% of their total caloric intake, or 25 to 30% of their total caloric intake. So whatever number you came up with on the amount of grams that they needed based on their body weight, then we would divide that number so that way we could get into calories. And so that way they were always in a calorie deficit. For those who were losing weight and for those who were trying to gain weight, we would bump up their protein intake and bump up their calories a little bit. But what I've noticed is that tends to work. And I also have this thing that I want to kind of like the myth out there, or maybe it's not a myth, I just want to debunk it if it's possible, is that the more protein that you eat, the more expensive shit you have in the toilet.
Okay. So what's the question, Michael?
So the question is, number one, the grams per kilogram,
mm-hmm.
What is it? What should it be? Or should it be per pound, grams per pound? The formula that I kind of gave you there, is that one that traditionally could work? And then the last question is, if they're eating too much protein, are you ever going to give somebody too much protein? Are they just going to have expensive,
Now, the numbers you use for grams per kilo, you said 0.8 to 1 point something?
1.6.
Okay. 0.8 to 1.6. Well, 0.8 grams per kilo is the RDA, and the RDA is ungodly low. And people say, well, if you don't work out, does it matter? I'm like, it still matters if you don't work out, and I'll get into that. So I think 1.6, I even think 1.6 is too low. I think the ceiling, let me backtrack. If you're training and you have a goal, I think you should go to 2 grams per kilo or 1 gram per pound, depending on if you want to use the metric system or, the imperial units. So why is that? Well, if you were to ask, and this is where sports nutrition, it's sort of part art, part science. If you were to ask, I was about to say 100 sports nutrition scientists. I don't even think there's 100 of us. If you were to ask 30 of us who do research in this, if 1.6 grams per kilo is, sufficient for meeting the goals of most people, I'd say 90% of them would say yes. Okay. However, the way I frame it is, well, okay, we each have a goal, whether it's to be stronger or larger or faster in whatever sport. If you go above 1.6, there is definitely a diminishing return, and people will hear that and they'll say, well, then why should I go over it? It's a diminishing return. And my response is, it's still a return. It's just, if you go from 0.8 to 1.2, you get a lot of benefit. If you go from 0.8 to 1.6, it's a lot better. If you go from 1.6 to 2, it might be marginally better. But for people who compete, marginally could determine first, second, or third place. Now, I wrote a paper, I think this was 5 years ago, and I said anyone who's a high-end athlete or trains seriously for an event, and I'm not talking about people who have necessarily make money. Let's say, in South Florida, we got duathlons, triathlons, running races, so many events that people are trying to win, even though they're not professional athletes. And when I talk to those people, they want to know every little thing that might help them, even if it only helps minutely. And that's why it annoys me when a lot of sports nutrition scientists are what I would call they're minimalists. They're like, well, 1.6 will work. What about 1.8? 1.8, maybe not. I'm like, how about maybe? What about 2.0? Maybe. I can give you specifics on, there's two athletes I work with. One is a world-class paddler. One is actually my wife. She's probably a world-class cyclist, masters. They are both on very high protein diets. And when I say high, anything over 2 grams per kilo. And I think my wife is actually 3 grams per kilo. So people ask, well, why is it so high? Well, there's 2 reasons. One, that much protein, you recover a lot better, much better than 1.6. And they both train like crazy. The other thing is, when you're on that much protein, your body composition is a lot better. Now, here's the thing that is strange about the 1.6, which most people will agree with. I'll be honest, most people don't agree with me. The problem with the 1.6 is, okay, let's say you hit 1.6. Now what? So now you just eat carbs and fat? This is what's fascinating. None of these people ever say, well, let's put a limit on carbs and a limit on fat. None of them do. But hey, let's put a limit on protein. I'm like, unless you compete in ultra endurance events, I don't think you need a high carb diet. I mean, it should be moderate carbs, but it doesn't have to be high. Like high meaning anything over 5 grams per kilo. I've seen recommendations of 10 grams per kilo for carbs. I'm like, who the hell eats that much carbs unless you're, for instance, if you're doing the Tour de France, you're just using so much energy that you got to just eat all that stuff. So to me, the higher protein intake is because I don't view this as a minimalist. I view this as do every little thing that can possibly help, even if it takes, let's say it takes, a minute off a half marathon time. To most people who don't know anything about running, they're like, a minute. I'm like, a minute is a lot. If a runner you could say, I'll take a minute off. You're not go like, what do I do? What do I do? So I think it's a question of philosophy. I'm not a minimalist. I'm not someone who says, well, you only need to lift twice a week to achieve a goal. Well, what about 3 times a week? Well, diminishing return. What about 4 times a week? Okay. Now it's really a diminishing return, but it's still a return. So that's how I address the protein intake issue.
Any problems with your gastrointestinal tract or any of the organs because of the high consumption of protein? So if you're going, let's say that 3 or 4 grams per kilogram of body weight.
Mm-hmm. We did a series of studies in the 20 teens. The longest one we did was 2 years. We followed all male bodybuilders consuming 3.5 grams per kilo. We did blood work on them. There was nothing happened. Liver's fine, kidneys fine, blood lipids are fine. We did a 1-year study on trained female athletes. Again, nothing happened. Bone density's fine, kidney function fine, liver fine, glucose fine. We literally have found no side effects. Now, I'll argue the other side of that. They're like, well, what would happen if, the lady down the street who just likes to walk her dogs 3 times a week, would it help her to eat that much protein? And my answer is this: she won't eat that much protein. because eating that much protein is actually work. People don't realize how hard it is to eat 3 grams per kilo. That is hard. And even for a lot of people, unless they're bodybuilding, 2.2 grams per kilo is still a bit of work. I mean, at my university, I know a lot of the athletes, and I'm actually not surprised when most of them are actually underfed when it comes to protein. I think some of them are lucky to hit 1 gram per kilo. And these are collegiate athletes. So as far as the harm, there's literally no evidence that eating a high protein diet, i.e. 1 gram per pound or more, has any harmful effects. So again, it's a question of philosophy. I am not a minimalist. I think if your goal is to be as best as you can be, do every little thing that might help. And that applies to supplements as well. People are like, well, that supplement might help. I'm like, yeah, you know what? It might help, but it's not going to hurt. And that's why you try it. Now, as far as, you bring them the idea that it's expensive poop if you eat a lot of protein, or, I hear the same thing with vitamins. Oh, it's just expensive pee.
Right.
Protein doesn't if you think about it, if you buy a tub of whey protein, it's cheaper than a gallon of milk. So protein actually is not that expensive. And also, when people say you got expensive urine from multivitamins, I'm like, multivitamins are not expensive. This stuff is cheap. It's a commodity now. So I don't buy the argument that it's expensive. But at the same time, if you don't have a goal, like if you just, I kind of work out, I feel better, I eat well most of the time. I'm like, you know what? You don't have to do this stuff. Just eat well. But if your goal is to be the best you can be, I think you should do everything you can.
Is there a difference? Because some professionals say, well, whey protein is not what you need. You need something that's going to be better absorbed by the body. So maybe you need something that's like a whole protein, a whole meal protein. So get something like beef protein or egg protein. So is there a recommendation from you based on what you've studied and researched?
Ironically, out of all those, whey protein probably has more data than all of the rest combined. So whey protein, based on the data, may be the single best source. Now, to me, there's a caveat there, because when people say, well, what's the best protein you should eat? And I actually say fish, and not necessarily because of the protein, but also because of the fat. Because fish has great fat in it. So to me, the single best food you could eat is fish. Now, if the goal is just protein, to me, whether it's fish, beef, chicken, whey protein, milk-based protein, I think they're all good. It's good to get a variety of them. I don't see an inherent advantage other than as a post-workout meal. I think, whey protein shake is better than all of them. It's not like you're going to eat, fish fillet after working out. That would not be recommended. But I think the convenience of whey protein or any of these protein shakes, protein ready to drinks, I think is great for most people.
Any detail on, whether it's hydrolyzed or isolate or how it gets broken down in the body? Does any of that stuff even really matter?
I don't think it matters for 99.9% of the population. If you're getting, put it this way, if you're getting 1 gram per pound of protein, it almost doesn't matter the source, because now you're on a high protein diet. However, if you're getting, did I say 1 gram per pound? Yeah, 1 gram per pound. Yeah. But if you're getting 0.8 grams per kilo or 1 gram per kilo, then quality does matter. So if it's hydrolyzed, it's better. Animal-based proteins better than plant-based proteins. But again, that's because your protein intake is so low that quality plays a role. But if it's over 2 grams per kilo, you know what? I don't think it matters as much.
I read a research study several years ago. I can't remember who wrote it, on soy protein. And how soy protein increased estrogen levels in men. And I think there's some stuff that has resurfaced since then. What's the consensus on that?
Yeah, the consensus on that is soy protein is one of the few plant-based sources that are good. It has all the essential amino acids. I don't think the data on it, I don't think it'll feminize men. I don't think most men consume enough soy for it to matter. To me, it's just one protein source out of many. On the flip side is I don't know many athletes that use soy protein. So they prefer, I think a lot of it is a taste issue. The best tasting proteins out there are still milk-based and mostly whey.
Yeah, they mix better and they taste better.
Yeah.
So I want to jump over into, you talked a little bit about, your dissertation and the research that you did around that. And did you ever get into myostatin? Because okay. So let's jump into hyperplasia then, because hyperplasia is something that I don't know if a lot of people who are listening know a lot about, but it is something that occurs in animals. Cats have hyperplasia where they actually create more muscle fibers. Right. And hypertrophy is where we're it's this knowledge that we just have the amount of muscle fibers and muscle cells that we have, and they continue to grow in size. So if I said that wrong, please correct me. But what is it, or is it possible for humans to ever experience hyperplasia, or is it possible to increase the number of muscle cells or muscle fibers that we have, so that way we have more growth?
Mm-hmm. Hyperplasia. You say hyperplasia, I say hyperplasia.
My instructor was from Australia. So he also said the Caribbean or Caribbean. I can't remember how he said it, but it was one of the two. So I had... Yeah, outside the U.S., I'll even hear mitochondria. I'm like, mitochondria. No, mitochondria. Okay, well, I guess it's all the same. Hyperplasia. Okay, there's data in rats lifting weights, cats lifting weights, birds sort of lifting weights. It's more of a chronic stretch with a weight where they get significant increase in muscle fiber number or hyperplasia. Mm-hmm. The mechanism for that is typically you activate satellite cells. Satellite cells are stem cells that sit outside of a muscle fiber, and satellite cells divide and they fuse with each other and they form brand new fibers, i.e. muscle fiber hyperplasia. So the question is, would humans undergo muscle fiber hyperplasia? And the sort of the simple answer is, well, why wouldn't they? If cats can and rats can and birds can, what would be so special about humans that they can't? The mechanisms are there. Humans have satellite cells. Humans can stimulate satellite cell proliferation. What stimulates it? Well, contractile activity. Muscle damage is something that stimulates satellite cell activation and proliferation. So there is a mechanism there. Now, the problem in humans, obviously, is you can't take out an entire muscle and count it. Most humans don't go for that. So you're left with very indirect methods. And what's the indirect method? There's actually old data, and I think it was Duncan McDougall, and I'm not even sure he's around anymore. He was a Canadian physiologist, and he did biopsies of bodybuilders. And I remember there was this one study showing he did muscle biopsies of the deltoid, and he compared bodybuilders to controls. And he found that the muscle fiber size was the same, the average size between bodybuilders and controls, even though the mass of the deltoid clearly was larger in the bodybuilders. So the only logical explanation would be, well, they produce more muscle fibers. Now, the other explanation I heard, which I thought was kind of funny, is that, well, these bodybuilders are just born with more muscle fibers. I'm like, the reason that doesn't make sense is, because my question would be, okay, they're born with more muscle fibers, so years and years of training made them the same size as people who don't work out. Is that what you're saying? And of course, that doesn't even make sense. So they were born with all these teeny tiny fibers and training made them average? No, that's just stupid. So to me, the logical explanation is they increase muscle fiber number. Now, the question in humans is, how do you induce that? And to me, the way to induce it is do the things that induce hypertrophy. It'll be the same stimuli. Whatever induces hypertrophy eventually will probably induce hyperplasia. I think muscle damage is part of it because of the, activation of satellite cells. Mm-hmm. But the average guy, for instance, the average guy who goes to the gym, likes to lift weights, maybe he plays basketball on the weekends, maybe he does some cardio, they ain't getting no hyperplasia. I mean, they're not training hard enough for it to matter. But if you're talking about high-end bodybuilders who are also on performance-enhancing drugs, I would
bet 100% that there's muscle fiber hyperplasia. To attain that level of muscle mass, there's got to be an increase in muscle fiber number.
So that's a stark difference from what I was taught years ago, which is why I have you on the show.
What's years ago? Because your time frame and my time frame of years
ago. So, that was 2006, 2007.
Oh, wow. Okay.
So plenty of time for a lot of research, more research to come out on this.
I would highly recommend for your audience. I wrote a nice review on, it was called Skeletal Muscle Fiber Hyperplasia. It was published in Medicine and Science and Sports and Exercise. It's probably one of the best reviews. I mean, I wrote it, so it's pretty damn good. For anyone interested, I think read that. It explains all of the data as it relates to animal models and human models.
That's really good. And there's no, because we know that myostatin inhibits the muscle growth, right? And it's in all
it's a negative regulator of hypertrophy. Yeah. So
actually,
I have a story for that. You want to hear the story?
Yeah. Please.
When they first discovered myostatin, I think I was in Texas. I was a grad student or postdoc, I forget which. There was a gentleman at Johns Hopkins who contacted me, and he wanted to get do biopsies of bodybuilders, look at their DNA, to see if they had the myostatin gene, or if it was turned off. And he published it later on. God, I wish I remember his name, but basically he found that they were all normal. There was nothing. There were no myostatin mutants in these bodybuilders, which demonstrated that for the most part, you can attain a large muscle mass. One, if you train hard. Two, if you take any kind of anabolic substance, primarily, testosterone or any of its derivatives. So yeah, none of them they had the mutation for myostatin, which is really, and he examined a lot of bodybuilders.
Yeah, that's interesting because the knowledge that I've had up until this conversation is that myostatin would inhibit, and everyone had it was regulated, depending on your own genome and how you had been created, right? So some of them had it turned off and some of them had it turned on, and there was a limitation for certain people. So that is really interesting. The reason why I bring some of these things up is because a lot of this is relatable to the audience, the gym owners, the trainers who are listening to these things, and a lot of these components they just don't have that information on. So I want to jump into really, what is it that you think is going to be the next big thing in supplementation?
Next big thing in supplementation. Well, one I could tell you, a couple cool projects I'll be involved in. The first one is on creatine. It's like, creatine, that's been studied to death. However, it has not been studied in the muscles of the eye. And I don't know if do you have a biology background? You do, right?
Exercise physiology.
Okay. So as you know, the eye, you have the most of the muscles of the eye are innervated by the third nerve, oculomotor. Mm-hmm. And then the lateral rectus is innervated by, I believe, the abducens or trochlear. And then the superior oblique, SO4, is the trochlear nerve. So you have the trochlear nerve, the oculomotor nerve, and the abducens nerve innervating the eye muscle. So it's skeletal muscle like any muscle. So if you take creatine, there should be an uptake of it to your extraocular muscles. So you're like, oh, well, okay, so who gives a shit? Well, think about it. What sports require that your eyes track fast-moving objects?
Yeah, all of them.
Yeah, baseball, softball, fighting. Think about this. You have to track a fist coming to your face, and to avoid getting knocked out. So does creatine affect those extraocular muscles such that it makes you track better? The funny part is no one's even asked that question because it seems like an obvious question. And it just sort of came up. My friend Tony Ricci, he also is a faculty at Nova Southeastern. He trains fighters, and it's just something he's thought about. And we're working with a gentleman in the department of optometry. He's an optometrist. We're going to figure out how to measure eye tracking and see, one, do athletes do it better than non-athletes? I would guess they do. Two, does creatine help eye tracking? And if we find that out, then, I mean, think of the implications for all the sports that, you got to track object. I mean, shooting, skeet shooting. Yeah. You see an object in space, you got to track it. So that's, I think that's super cool. The other one is I am on the Science Advisory Board, Science Advisory Commission of the Enhanced Games. I don't know if you've heard of the Enhanced Games.
I haven't. This is new.
It is, I think the website's enhanced.org.com. You'll like this, Michael. You'll at least find it fascinating. The Enhanced Games, I'll try to summarize it because there's a lot of moving parts. It's games where athletes can take performance-enhancing drugs. And we monitor it, and we actually will be studying the effects of these drugs, primarily testosterone and its derivatives and or EPO, the effects of these drugs on, whether it's track athletes or swimmers, to see how it impacts performance. But also, we're going to monitor their health. There's a group of physicians that'll be part of it, monitor their health. And this will be the first time ever that we will have scientific data on high-end athletes taking performance-enhancing drugs, which seems odd because shouldn't we have that data? Well, we should, but the problem is no one wants to study it, because of, I guess, you don't want to be blackballed. It's like, oh my God, you're studying drugs. It's like, right. Yeah, but you're taking it anyways. I mean, people think the Olympics is clean. I mean,
that's hush hush. Yeah.
Yeah. Do you think none of them are taking PEDs? I mean, you'd have to be.
Yeah, they got to be taking something.
Yeah, you'd have to be really naive. So that's going to be really interesting. So those two things are really super cool projects that we have coming up.
That's interesting on the Enhanced Games, because I have a feeling that some of those athletes who currently are involved in professional athletics are going to say, you know what, I can't get involved in the Enhanced Games, because then what does it say about me being in my other career, my other sport? So you'll probably get a lot of ex-athletes who are no longer in the game, or those who didn't actually end up making it professionally, and they just divert. Yeah,
like for instance, if you're a competitive track and field athlete, you're not going to compete in this because you're already competing, let's say in USA Track and Field or World Athletics.
Topics of it are really bad. You're probably going to get disqualified.
The flip side of this is most athletes are poor. We only know about the rich ones because they're the ones who win. You never hear about the guy or girl who gets 8th place. They're poor. Almost all of them are poor. In the Enhanced Games, athletes get paid. So you gotta, as an athlete, your career is very short. It's very short. Okay, how can I make money in this field? Especially, let's take the simple sports, track. You're running a distance. These guys don't last that long. I mean, Usain Bolt was an exception. He did well over the course of several Olympics. But I challenge most people to name one other sprinter beside Usain Bolt. They can't name anyone. And that guy who finished 8th at the Olympic Games,
nobody knows.
Imagine this. You're the 8th fastest guy, and you're still poor. So the 8th fastest guy in the world, what would happen if he was put on a systematic performance-enhancing drug schedule that was monitored? How well would he or she do? And the answer is nobody really knows because no one's really done it. I think this will be the interesting sort of cultural revolution that might come out of it. Let's say this happens, Michael. So it's probably older athletes. Let's say they're maybe in their 30s and it's like, okay, I'm at the tail end of my career. Maybe I can boost it a little. Let's say after a year or whatever number of months of using some of these performance enhancing drugs that they perform better. Maybe they break a record, maybe they don't, but there's no harmful side effects. Now, what's the cultural implications of that?
Yeah.
Because we've been taught since we were little that they're harmful. But if we show that they're not harmful, what can people say now? They can't use the argument, well, the reason the Olympics bans these drugs is, we're preserving the health of the athlete. And I know that's bullshit, first of all. But let's say we have data showing it's not harmful. What will be the argument against performance enhancing drugs?
All of a sudden, supplements get a superpower.
Something. Yeah. Exactly.
Yeah. Man, this is good stuff. And I know that I could keep going on. But I want to make sure that because I've gone over with time for you, and you were gracious enough to allow me.
We can always do a part 2 another time.
Yeah, because I have so many more questions, even things that just came up as we're talking. But I got to say, Dr. Antonio, like, great information. You've already, dispelled some things that I thought were one direction, even just on the protein intake and creatine. I wanted to get into more. I wanted to talk about different types of muscle fibers. Carnivore diet, the different types of diets that are out there.
Oh, God, yeah. You could talk forever about this.
Yeah. So I'd love to have you back on in maybe in a couple months after you get done with the conference. But for all those who are listening,
come to the conference. Make sure you come say hi. I'm easy to find.
Yeah, I definitely will. I mean, I'm only a couple hours from Delray, so it's a quick trip for me.
Yeah, and I could introduce you to other guys and girls who would be great guests on your show.
Oh, yeah. that would be fantastic. That really would be awesome. So for those of you who are listening, where to find Dr. Antonio, you can go to ISSN. He has, I think you've got a certification course as well.
Our certification, the initials are CISSN. It's a sports nutrition certification. It's heavily science-based. It's a very difficult certification. If you don't have an undergrad degree in exercise science, I think it would be very difficult to pass. Although there have been rare exceptions. I think out of like the 5,000 people who've taken it, I think 2 passed it who did not have an undergrad degree in exercise science. So, but it's super difficult. But I highly recommend it for anyone who's working in a field where you're dealing with performance athletes.
Okay. And then where else outside? I mean, you got the conference coming up on, what is that, June
23 to 25 in Delray Beach, Florida. It's at the Opal Grand Resort right on A1A. So the beach is right there. You can always go to the beach if you get bored with the conference. The website for that is ISSN.net. So register there at ISSN.net. The rates go up June 1. So make sure you register now before June 1, before the rates for registering go up. I can be most easily found I'm on X at, my X profile is Jose Antonio PhD. I'm also on Instagram under _ISSN, where I post everything related to the organization. And then I have my personal Instagram page, SUP PhD. I post stuff about my podcast, about paddling. In fact, I'm doing a paddling race on Saturday, just down the street from us. So yeah, those are the easiest ways to reach me. And I try to answer all direct messages or emails as quickly as I can.
Thanks, Dr. Antonio. And I've got something special for everyone at the end here, and we'll put it in the show notes. But there's a nice special opportunity for you to be able to get to the conference, and we will reveal that here shortly. Dr. Antonio, thanks for coming on and giving me more time than I was allotted. And I'm looking forward to seeing you at the conference and having you back on the show.